In this video, we're going to start looking at how the SQA pitch volume at exam standard. Now, I'm not going to give you every single question the SQA have pitched. I'm just going to look at a few of the examples I've seen recently that I think are worthwhile looking at. Okay, so this is not an exhaustive list. There are lots more for you to have a look at, but certainly it's a few of them to have leave room for thought. Okay, now here's an example. A candle is in the shape of a cylinder with diameter 10 centimeters and height 15 centimeters. Calculate the volume of the candle. Give your answer correct as 3 significant figures. So, this is worth 3 marks, which means we've got a bit of work to get done with this. It's given us nothing in terms of the diagram, but it has tells us everything that we need to know in terms of the question. We're told, for example, that the diameter is 10 centimeters, so that means from here to here is 10 centimeters. Well, we're never interested in the diameter though. We're interested in the radius going from here to here. So if the diameter is 10, that means the radius is 5 centimeters. We're told that the height is 15 centimeters. Okay, now if you don't remember from back when we did the volume of a prism episode, we can use other formula that we've been given on the formula list. If we think about it, a cone is just a cylinder that's had the bits shaved off either side. Okay, the cone's formula is a 1/3 pi r squared h, but the volume of a cylinder, volume equals pi r squared h. So it's the same as the volume of a cone, but without the 1/3 at the front. It's always a good thing to sort of remember. And if you're wanting at the beginning of an exam to write that onto your formula list, then please feel free. There's nothing wrong with doing that. So volume of a cylinder, pi times r squared times h. Well, that's pi. Your radius is 5 centimeters, so squared times 15. And this is where we get the calculator involved. So pi times 5 squared times 15 gives us 1,178.097245. Alright, now this is where we have to start thinking, what are we supposed to round it off to? We have to go back at this point, check the question, because one of the things we've not really taken into account is where are we supposed to round it off to? So calculate the volume of the candle. Give your answer correct to 3 significant figures. So remember, 3 significant figures meant we look at the first 3 non-zero digits, that's the 117. We look at the 4th digit down. 8 we know rounds up, so the 117 becomes 118. And because this is in front of the decimal point, we have to put a 0 there. Centimeters cubed. Done. So our 3 marks would be allocated, 1 for getting the numbers put into the formula correctly, 1 for getting an initial answer, and 1 for rounding it off correctly at the end. That's normally how it's being given to you. So a second candle is in the shape of a cone with circular base of diameter 14 centimeters and height 8 centimeters. Right, well, every time I see diameter there, I'm always tempted just to put that in and say 7. Let's just do that now before we forget. It says it has the same volume as the first candle. Right, so our volume, the last one was 1,180 cubic centimeters. So we know the volume is 1180 centimeters cubed. And it says calculate h, so that's the height. Now, we know that the volume of a cone, which I've already mentioned it, is 1/3 pi r squared h. So that's, we know that the volume is 1180. But pi, the radius is 7 squared, and h is the thing we don't know. So all we've done there is we've substituted in what it is we know. We have to rearrange something very, very shortly to get what h is on its own. So what I like to do is I like to think to myself, well, this is 1/3 pi r squared, that's timesing the h. So all this stuff here is multiplying the h. Well, how do you undo a multiply? Well, we divide. So what I'm going to do is I'm going to take this bit to the other side and divide by all of this here. So h is going to be left on its own. I've got the 1180, and it's being divided by everything that is moved. Now, we will be looking at change subject of a formula later on in the course, but for now, that will be good enough. That will get you to the right answer. So, again, this is where we get to use our fraction button properly. On the top, we've got 1180. On the bottom, we have, in brackets, 1/3 pi times 7 squared. Remember to close your brackets as well. That gives us 22.99, so h equals 22.996, etc. Notice I'm just putting the 3 dots in there to highlight that there are extra digits afterwards, just that we don't care that much about what those digits are. But fundamentally, it's pretty much 23.0 centimetres. Okay, so again, that was worth 3 marks. 1 mark for managing to put it back into the formula for a cone, 1 mark for managing to rearrange it, and 1 mark for your final answer. Okay, so that's 6 marks in total. That should take you about 9 minutes when you're doing that in the final exam. A second example we've got here, an ornament is in the shape of a cone with diameter 8 centimetres and height 15 centimetres. The bottom contains a hemisphere made of copper with diameter 7.4 centimetres. The rest is made of glass as shown in the diagram below. So let's just get grips here. We're told that the diameter of the copper bit is 7.4, but the diameter along the bottom is 8. So this is not the same distance across. Calculate the volume of the glass part of the ornament. So what we've done there is we've started off with a piece of glass, and then we're going to put some copper inside the glass. So we've actually removed a bit of the glass to put copper inside. So another way of saying that we're removing something is a take away sum, like a subtraction. So I know I've started off with the volume of a cone, and I've subtracted the volume of the hemisphere. Okay? So what I need to do then is work out the volume of the cone, work out the volume of the hemisphere, and subtract one from the other. So my volume of a cone, we know is 1/3 pi r squared h. It's on your formula sheet, please make sure you use it. We know the radius of the cone is going to be 4, and the height is going to be 15. So it's 1/3 pi times 4 squared times 15. 1/3 pi times 4 squared times 15 gives me 251.3274 ... Notice I'm not rounding it off at this point. Volume of my hemisphere. Well, I know that the sphere is 4/3 pi r cubed. I remember from the video when we looked at the sphere, if it's a hemisphere, we have to divide that by 2, okay? Now, we're told that the diameter was 7.4, so my radius here is going to be half of 7.4, so 3.7. So it's going to be 4/3 times pi times 3.7 cubed divided by 2. The most common error we see when everybody's doing a sphere tends to be that they tend to either miss the power completely or they put a squared instead. Please make sure you're putting the cube in there. So 4/3 pi times 3.7 cubed divided by 2 gives me 106.0783, etc. So volume of the volume of the glass is equal to that. So we say that's going to be 251.33 roughly, if we just round that off here, minus 106.09. This class has been good enough. You've shown that you understand the basic principles behind it. Chances are at this point you won't be penalised too much in terms of rounding, if at all. 251.33 minus 106.09 gives me 145.24 centimetres cubed. So 145.24 centimetres cubed. That is worth a grand total of 5 marks. So you tend to get marks for knowing how to substitute into the cone and getting the right answer, marks for getting the sphere correct as well, and knowing that you're going to take one away from the other and getting your final answer. Should be straightforward enough, okay? So please take time to have a look over that as well. And another exam favourite here, okay? So the idea is we've got a shape and we've cut a bit off the bottom. So it's another subtraction. We've got 2 cones. So it's saying a carton is in the shape of a large cone with a small cone removed, usually like an ice cream carton. Large cone has diameter of 32 centimeters and a height of 24. That small cone has a diameter of 18 and a height of 13.5. Now the fact it says large cone and small cone means you have to differentiate between the two. Calculate the volume of the carton. So we know it's going to be volume of the large cone minus volume of the small. So that's the volume of the carton. Okay, so over here, volume of the large cone is 1/3 pi r squared h. So 1/3 times pi. Radius of the small cone, this bit at the bottom here, is 8, as well as the diameter is 18, so that must be 9 squared. And the height is 13.5. So straight into the calculator, 1/3 times pi times 9 squared times 13.5 gives me 1145.1 centimeters cubed. Volume of the small one, again 1/3 pi r squared h, so 1/3 pi, so on, 16 squared. Height is 24, equals, so 1/3 pi times 16 squared times 24 gives me 6433.98. 6433.98 centimeters cubed. I've got them the wrong way around. That should be the small one, and that one there should be the large. Okay, otherwise it doesn't make sense. The small one's the one at the bottom, the big one is the large one. Okay, so now I've got those two answers. I will substitute them straight back in here. The large one was 6433.98. Small one we said was 1145.11. And again, minus 1145.11. 5288.87 centimeters cubed. And just make sure we've got it rounded off correctly. Give your answer correct to 2 significant figures. 2 significant figures, look at the third one down as an 85300 centimeters cubed. Another 5 marks. There are loads of them just like this. I know this has been a longer video, but please make sure you're trying some of the past paper questions. They will help you out in the long run, and certainly we'll be looking at them when we're in class as well. Okay, thanks.